2.2 is all about conditional statements. First of all, what is a conditional statement? A conditional statement is a statement that can be written in the form if then. The direction below gives an example of a conditional statement. If you would like to speak to a representative, then you will press 0 now. So that if then part is what makes a conditional statement. I don't know what psychopath created this or picked these letters, but they picked P and Q. So a conditional statement follows the pattern if P, then Q. This little symbol in here, the arrow, is like the word implies. So P implies Q. I don't know why we picked those, but that's what we got. P, then Q. The P part represents the hypothesis. It's all the words that follow the word if. So P is the hypothesis. And in this example, my hypothesis is you would like to speak to a representative. Notice, I don't include that word if in my hypothesis. If is just one of those filler words. On the other side, after the word then, we have the conclusion. The conclusion is represented by the letter Q. And again, it's all those words that follow the word then. In this example, you will press 0 now is our conclusion. Questions on that? Okay, so basically what we're going to be doing is we're going to be taking sentences and writing them in this form. If something, then something else. We call that literally just the conditional. Okay, the conditional is the original form. And again, the order of the things is that we have P implies Q, or hypothesis implies conclusion. An example that we might see is something like, if two angles are vertical angles, then they are congruent. Would we say that's a true statement? If two angles are vertical angles, then they are congruent. Right, that's our definition of what a vertical angle is, right? They're across from each other, so they're congruent. So I would say, like, this conditional statement, yeah, that's true. Cool? Then everything else that we do is basically just another form of the original conditional statement. So there's 3 different ways that we can kind of change around the order and the meaning of this same sentence. So the first way is the converse. The converse is when we exchange the hypothesis and the conclusion. So we read this as Q implies P, or conclusion implies hypothesis. All we did here was we reversed it. So it would look like, if I'm looking at the same exact kind of statement here, if two angles are congruent, then they are vertical angles. Does this mean the same thing? Is this still as true as the last one was? If two angles are congruent, then they are vertical angles? Are there ways that we can have two angles be congruent that aren't vertical angles? I would think, yeah, right? They don't have to be vertical from each other to be congruent. I could put two angles like across from each other, and they could still have the same measure and be congruent. So even though that first one is true, when I flip around some of my words, I can change the truth value of a statement. Questions on that? So that one is just flipping the order. Hypothesis comes after conclusion that time. Now, something else that we can do with our statements is we can what we call negate them. So I can do the opposite of a statement. We see this little symbol right here. That's like a little squiggle. That means not. And if I just take my original conditional, P then Q, and I negate both of them, so I have not P implies not Q, then I get what is called the inverse. Okay? All the inverse is doing is replacing the hypothesis with a negative hypothesis, replacing the conclusion with a negative conclusion. So this says, if two angles are not vertical angles. Notice that word not in there. Then they are not congruent. Again, noticing that word not in there. And again, we could say, hey, I don't know, that one seems like it's false, right? If they're not vertical angles, then they're not congruent. Well, we already said I could put two angles next to each other that aren't vertical, and they could still have the same measure. They could still be congruent. So I would say that one's also probably false. The last one, the contrapositive, the longest of the words, is when we do both things. We're going to flip the order and we're going to reverse, or we're going to negate the meaning. So I put the conclusion first, then I put the hypothesis, and I'm doing the negative version of each one. So if two angles are not congruent, see that word not, then they are not vertical angles. If two angles are not congruent, then they are not vertical angles. This time I would say, yeah, that's a true statement, because if they were vertical angles, then they would be congruent. So if they're not congruent, they must not be vertical angles. I would say that's true. You absolutely need to know the difference between these four things, and we're going to talk about the last one in a second. But you need to know the difference between these four things. You need to know how to write them, the correct order, whether they need a positive or a negative statement in there. You got to know these. This is like the big part, well, not the biggest part of this unit, but it's a big part. Questions on that? Okay, the last one is called a biconditional. Now, I talked a little tiny bit about this earlier in Unit 1. Do you remember when I told you that the statement if and only if is represented by this abbreviation, IFF? Do we maybe remember when I said that? I said it very briefly. So a biconditional is when both the original statement, so my conditional, and the converse, which means I flip the order, when both of those things are true, then I can write a biconditional for that statement. The example that we've been using so far doesn't work. One was true, one was false. So here's a new example. It says, an angle is a right angle if and only if it measures 90 degrees. What this means is it's true both ways that I say it. If an angle is a right angle, then it measures 90 degrees. True. If an angle measures 90 degrees, then it is a right angle. Also true. It's true both ways. We can write a biconditional that is true. We use the phrase if and only if, and this is our symbol. It's a two-way arrow. So P implies Q and Q implies P. Questions on that? Okay. All right. So some of these things are logically equivalent just by nature. Always, all of the time, your conditional statement, which means your original statement, and your contrapositive are going to be the same truth value. Oops, that's not what I meant to do. So the conditional and the contrapositive will either both be true or they will both be false. Similarly, the two that end with verse, converse, inverse, those are logically equivalent. They will either both be true or both be false. Okay, so you could have all four be true, you could have all four be false, but these pairings will always have the same truth value. Questions on that? All right, flip it over when you're ready. I'm going to be picky. Please don't be mad at me. I know we're in a math class, but I do want to see things with capitalization and punctuation. I'm sorry, I know. please just do it. Punctuation, capitalization, like you're writing in an English class. Your sentences that we are writing right now, they should make sense. So, identify the hypothesis and the conclusion of the following statement. If a polygon has 6 sides, then it is a hexagon. We're going to start with the hypothesis. What is the hypothesis in this sentence, in this statement? Casper. We're not going to include that word if, but I will say the hypothesis, P, is a polygon has 6 sides. So if and then are never part of our hypothesis or our conclusion. What is our conclusion then? It's just that other part of my sentence, right? If the first part was my hypothesis, it is a hexagon is going to be my conclusion. Questions on that? Easy enough. We have P and we have Q. Number 2, write the statement as a conditional in the if-then form. Measured distance is positive. How would we write this in if-then form? Anybody want to give it a try? No one's brave. If we do what? What are we doing here? If we... Casper? Perfect. If we measure distance. So we measure distance, that's our hypothesis. Conclusion, what's our conclusion? Then, go ahead. The distance is positive. True statement, right? Distance is always positive. There we go. I put a period at the end here. Punctuation, capitalization, all good things. If we measure distance, then distance is positive. Number 3, determine the truth value of the conditional statement. If it's true, explain our reasoning. If it's false, we're going to give a counterexample. Do we remember counterexamples from yesterday? It's just something that proves something is false. So if last month was February, then this month is May. True or false? We know that's false, right? What's the counterexample? If last month was February, then this month is May. What's the counterexample? Why is this false? Oh man, I know we know our months. Yeah, Caitlin? Yeah, the month after February is March, not May. So this is false. And our counterexample could just be the month after February is May. Or sorry, is March. Did I say May? Perfect. Questions? We're getting there. Number 4, consider the true conditional statement. Write its converse. If the converse is also true, then we're going to write the biconditional. So the statement is, if 3 points are collinear, then they lie on the same line. So I'm going to, first, I'd like to highlight my hypothesis, highlight my conclusion. I have my hypothesis, P. I have my conclusion, Q. And we know that a regular old conditional takes the form P implies Q. So what form does my converse take? Casper. Q implies P. We're going to take that statement and we are going to reverse it. So I'm going to use if. If. And now here's where we got to get a little specific. Because if I'm writing a sentence and I start my sentence like very vague, then I'm not going to understand what the rest of the sentence means. So instead of just saying, if they lie on the same line, I should really be writing, if 3 points lie on the same line. So be very specific. then, now I can be a little bit more vague, they are collinear. Our sentences should always start off a little bit more specific than they end. True or false? I think this is good. I think that's a good statement. If 3 points lie on the same line, they are collinear. I would think that's a true statement. That's kind of its definition, right? So let's go ahead and write our biconditional. Remember, our biconditional uses the phrase if and only if. Anybody want to give this one a shot? How would we write this? We're not going to use if then anymore. We're just going to have the statements. And then in the middle, if and only if. Gabby. We're going to put the if and only if in the middle. So we're going to try 3 points are collinear. If and only if they lie on the same line. So notice I don't have an if-then anymore. I just have if and only if in the middle, like a little sandwich. Questions on that one? Okay, a couple more. Write the two statements that form this biconditional. Lines are skew if and only if they are non-coplanar. What's my hypothesis? Go ahead. Casper, you got it? Is your hand up? Who's got it? Nolan, you got it? Somebody's got a hand up. What's my hypothesis? Don't be afraid. If and only if is in the center, right? We see it? So that means my hypothesis is going to be this first part. Lines are skew, P. My conclusion is going to be the second part. They are non-coplanar. So as an original conditional statement, if, hypothesis, lines are skew, skew, then they are non-coplanar. Converse, we're going to take that same exact thing, we're going to reverse it. So instead of if lines are skew, then they are non-coplanar. If, I'm going to be specific here, not if they are non-coplanar, but if lines are non-coplanar, then they are skew. Questions on that one? Okay, last one. Write the logically equivalent sentences to the following conditional. If you drink a glass of orange juice, then you will get a full day supply of folic acid. We're going to assume that's a true statement. I don't know much about the glasses of orange juice, but I guess that's probably true. So that's my conditional. It takes the form P then Q. Look back at your first page if you have to. What form is logically equivalent to the original conditional? I know 3 forms. Converse, inverse, contrapositive. Which one is logically equivalent? Casper. The contrapositive. And what form does the contrapositive take? Like if this one is P then Q, then the contrapositive is what? Go ahead. Yeah. Not Q implies not P. It is both negative and it is flipped. So let's write this out. I'm going to identify my hypothesis. You drink a glass of orange juice. I'm going to identify my conclusion. You will get a full day supply of folic acid. And I'm going to flip this. So the conclusion is going to come first. The hypothesis is going to come second. We'll start with if you will get a full day supply of folic acid. We want that to be negative, and we kind of want it to make sense the way that our sentence is going. So let's write, if you did not get a full day supply of folic acid, notice I added that word not in there to make it negative, comma, then, now I take my hypothesis, you drink a glass of orange juice, I'm going to fit it to my sentence to make sure that my sentence still makes sense, and I'm going to make it negative. So, if you did not get a full day supply of folic acid, then you did not drink a glass of orange juice. And now some of these are a little bit weird, right? If you did not get a full day supply of folic acid, you did not drink a glass of orange juice. Could you get your full day supply of folic acid some way else? I'm sure. But you for sure didn't drink a glass of orange juice, because if you did, you would have that supply of folic acid, right? Kind of weird statement here, but it is still logically equivalent, still true as the first statement up there. Any questions on that?